Hello everyone, this is a continuation video from earlier on where we explore how potential difference across electrical components varies according to resistance. Now in this example here, we have a specific electrical component known as the light dependent resistor. In short, it's called the LDR. The behavior of LDR is such that when the light intensity increases, the resistance across LDR decreases. And when light intensity decreases, the resistance across LDR increases. And light intensity refers to brightness. So to simplify explanation, I'm just going to use bright or dim. So we let the resistor across the fixed resistor be R1 and the resistor across LDR be R2. And the potential difference across fixed resistor be V1 and LDR V2, and the EMF across the circuit will be V. So there's two things we're going to look at here. How V1 and V2 changes in bright condition and then in dim condition. We start off with bright condition. When it's bright. So when the surrounding is bright, R2 decreases. And we know V and R1 are constant. And the current through the circuit is also constant. As mentioned earlier, is said to be constant because the current through R1 is always equal to the current through R2, because R1 and R2 are connected in series. So we can form the equation here. I equals V1 over R1. I is also equals to V over R1 plus R2. So that means I have V1 over R1 equals V over R1 plus R2. Now when the condition is bright, R2 decreases. And when R2 decreases, that means R1 plus R2 decreases, since R1 is really fixed. And since V is also fixed, that means V over R1 plus R2 increases. And that also means V1 over R1 increases. And since R1 is constant, that means V1 increases. And we know that V equals V1 plus V2. And V is a constant. So if V1 increases, that means V2 decreases. And there we have it. When it's bright, this is what happens to R2, and this is what happens to V1 and V2. Next, we move on to what happens when it's dim. So when it's dim, light intensity decreases, resistance across LDR increases. And we know V and R1 are constant. And from the equation formed earlier, V1 over R1 equals V over R1 plus R2. So when R2 increases, that means R1 plus R2 increases. And that means V over R1 plus R2 decreases. So that also means V1 over R1 decreases. Since R1 is constant, V1 has to decrease. And since V equals V1 plus V2, and we know V is a constant, and V1 decreases, therefore V2 must increase. So under dim conditions, R2 increases, V1 decreases, V2 increases. So generally that's how you analyze the circuit, and you also do notice I'm doing it step by step. Do it step by step, piece by piece of the puzzle, analyze piece by piece, and not the collective whole. Once you analyze piece by piece, it eventually forms the collective whole. It takes practice.